Okay, so this is just a second day of practice of factoring basic trinomials. Again, we want to follow this little table if it helps you. I'm just going to keep doing it the way that I've been doing the videos on these. So the sign of C always tells you if the signs in my binomials are going to be the same or whether they're going to be different. If C is positive, that means they're both going to be positive or both going to be negative. If C is negative, then one's going to be positive, one's going to be negative, and then it just depends where I put the numbers on those. So let's just jump right in. We always want to check for a GCF. Since number 1 does not have a GCF, we are going to go ahead and break it up into two binomials. So B times B is B squared. So since C is positive, that means these are going to be the same. And what I know they're going to be is because of the B. Since B is positive, that means they're both going to be positive. So that C tells you whether they're the same or different, but B tells you what the signs are, okay? So then I read it backwards. What two numbers multiply to get 7 but add to get 8? And the two numbers that come up are 7 times 1, because 7 times 1 is 7, and 7 plus 1 is 8. Now, it doesn't matter where I put 7 and 1 because they're both positive. And I can check my answer by foiling this out and seeing if I end up back at the beginning. Number 2, no GCF, so I'm going to break it up into two binomials. N times n is n squared. Since C is positive, that means they're both going to be positive or both going to be negative. But the B tells me what they're going to be. So since B is negative, that means they're both going to be negative. Then I read it backwards. What multiplies to get 10 but adds to get 11? And the two numbers that come up is 10 times 1. Because 10 times 1 is 10, but 10 plus 1 is 11. Since they're both the same, it doesn't matter where I put 10 and 1. Number 3, no GCF, so I'm just going to break it up into two binomials. Since C is negative this time, that means they're going to be different. One's going to be positive and one is going to be negative. So there's no the same sign on this one. What two numbers multiply to get 90 but subtract to get 1? And the two numbers that come up are 10 and 1. Not 10 and 1, sorry. 10 and 9. Because 10 times 9 is 90 and 10 minus 9 is 1. Now, the bigger number, it matters where I put the bigger number. I'm going to put the bigger number next to the sign that B is. So since B is positive, that means I need to put 10 with the positive and 9 with the negative. If I put it in the wrong spot, then I'm going to end up with a different B. So it matters where I put the bigger number on these. Number 4, since I have no GCF, I'm going to break it up into two binomials. Since C is negative, that means they're both going to be different. Okay, so I'm going to read it backwards. What multiplies to get 12, but subtracts to get 4, and the two numbers that come up are 6 and 2. 6 times 2 is 12, and 6 minus 2 is 4. Since 6 is the bigger number, I need to put 6 with whatever sign B is. And since B is positive this time, then I need to put 6 with the positive and 2 with the negative. Okay, number 5, no GCF, so I'm going to break it up into two binomials. C is positive, so that means they're both going to be positive or both going to be negative, and B tells me that they're both going to be negative. Then I read it backwards. What multiplies to get 9 but adds to get 10, the two numbers that come up are 9 times 1. Because 9 times 1 is 10 and 9 times 1 is 9 and 9 plus 1 is 10. Since they are both the same sign, it doesn't matter where I put the 9 and the 1. Number 6. Okay. C is positive, so that means they're both going to be positive or both going to be negative. Since B is positive, that means they're both going to be positive. Then I read it backwards. What multiplies to get 64 but adds to get 16? And the two numbers that come up are 8 and 8. 8 times 8 is 64, and 8 plus 8 is 16. And it doesn't matter where I put the 8s because they are the exact same sign. Now, I want to point something out on number 6. Since these are both written the same way, B plus 8 and B plus 8, you will see your answer written as B plus 8 squared. because all this means is b plus 8 times itself. So just be prepared if you see that. Continuing on, just a lot more practice problems with some GCF towards the end. Number 7, I'm going to break it up into 2 binomials because there is no GCF. Okay. Since C is negative, they're both, one's going to be net positive, one's going to be negative, and I read it backwards. What multiplies to get 24 but subtracts to get 2 is 6 times 4. Now, since 6 is bigger, it's going to go with the positive because B is positive, and 4 goes with the negative. Number 8, I'm going to go ahead and break it up into 2 binomials because there is no GCF. Since C is positive, they're both going to be positive or both going to be negative. They're both going to be negative because B is negative. Then I read it backwards. What multiplies to get 24 but adds to get 4, that would have to be multiplies to get 24 but adds to get 4. And to be honest, I think this is one of those. So this is one of those rare times where it's not possible. If I really think about it, there are no 2 numbers that I can multiply to get 24 and add to get 4. It's not possible. So this is one of those where it does not factor. And then, or you'll see it written as prime. So just be prepared for one of those. It's not that you're doing it wrong, it's just there's no possible combination. Number 9, 2 binomials. Okay, since C is positive, then that means they're both going to be both either positive or both negative. Since B is negative, that means they're both going to be negative. Then I read it backwards. What multiplies to get 40 but adds to get 13? Multiplies to get 40 but adds to get 13. And this is where I have to rely on my calculator a lot because I want to make sure that I'm doing it correct. So the 2 numbers that come up are 8 times 5. Okay, so then since they're both the same sign, it doesn't matter where I put the 8 and the 5. Number 10, going to break it up into 2 binomials. Since C is positive, they're both going to be positive or both negative. Since B is positive, that means both pluses. What multiplies to get 18 but adds to get 11 would have to be would have to be 9 and 2, because 9 times 2 is 11, or 9 times 2 is 18, but 9 plus 2 is 11. And it doesn't matter where I put 9 and 2 because they're the same sign. Okay, number 11. Okay, since C is negative, that means one's positive, one's negative. If I read it backwards, what multiplies to get 56 but subtracts to get 1? And that would have to be 8 times 7, because 8 minus 7 is 1. Now, since 8 is bigger, I want to put it with the negative because B is negative. And then 7 goes with the positive. Okay, 2 binomials. Since C is positive, they're both going to be the same. B tells me that they're both going to be negative. Read it backwards. What multiplies to get 6 but adds to get 5, and the 2 numbers that come up are 3 and 2. Since they're both negative, it doesn't matter where I put the 3 and the 2. Number 13, 2 binomials. And then since C is positive, that means they're both going to be the same. And since B is negative, that means they're both going to be negative. And then what multiplies to get 8 but adds to get 6 would be 4 times 2. It doesn't matter where I put 4 and 2 because they're the same sign. Number 14, 2 binomials. Almost looks exactly like number 13, but this time C is positive, but both signs are going to be positive because of the B. What multiplies to get 8 but adds to get 6, again, is also 4 and 2. But this time it's just the signs are positive on this problem. So same idea. Now we're going to jump into making sure you look for a GCF before you factor out the trinomial. So if I look at number 15, I have a GCF of 2. So if I look at what's remaining, 2n squared divided by 2 is n squared. 6n divided by 2 is 3n. And then 108 divided by 2 is 54. Now I can break this up, bring down my GCF and break this up into two binomials. Since C is negative, that means one's positive, one's negative. What multiplies to get 54 but subtracts to get 3? And my two numbers are 9 and 6. Since 9 is bigger, 9 is going to go with what B is. So B is positive, so 9 is going to go with the positive. My GCF for number 16 is 5. So 5n squared divided by 5 is n squared. 10n divided by 5 is 2n. And 20 divided by 5 is positive 4. Then I bring down my GCF and break this down into two binomials. So since C is positive, they're both going to be positive because B is positive. So sorry, since B is positive, they're both going to be the same, but B tells me that they're both going to be positive. Then I read it backwards. What multiplies to get 4 but adds to get 2? So if I really look at this one, what multiplies, let me make sure I did my math correctly here. Yep. What multiplies to get 4 but adds to get 2 is not possible. Because the only numbers I can multiply to get 4 are 1 times 4, but I can't add those to get 2. And what multiplies to get 4 is also 2 times 2, but I can't add those to get 2. So it stops right here. This one only has a GCF. There is no binomials on this one. So it's not a prime like this one because it does factor a GCF, but it doesn't go any further. Okay, number 17, a GCF of 2. So if I look at what's remaining, 2k squared divided by 2 is k squared, 22k divided by 2 is 11k, and 60 divided by 2 is 30. Then I break this up into two binomials while I bring down my GCF. So since C is positive, that means they're both going to be the same. B tells me that they're both going to be positive. And what multiplies to get 30 but adds to get 11 would be 5 times 6. It does not matter where I put the 5 and the 6 because they're both the same. If I look at 18, there is no GCF here, so it's just a basic trinomial. So then I'm going to, since C is negative, that means one's positive, one's negative. What multiplies to get 90 but subtracts to get 1, I feel like we did that one, close to the same, is 10 and 9. Now, since 10 is bigger, I need to put it with the sign where B is. Since B is negative, 10 needs to go with the negative. So then 9 goes with the positive. 19 is also one that does not have a GCF, so it's a regular basic trinomial. Since C is positive, that means they're both going to be the same. And since B is positive, that means they're both going to be positive. Now I read it backwards. Where it multiplies to get 10 but adds to get 11 is 10 times 1. And it doesn't matter where I put the 10 and the 1 because they're the same sign. Last but not least, this one does have a GCF of 5. So 5v squared divided by 5 is v squared. Negative 30v divided by 5 is negative 6v. And 40 divided by 5 is positive 8. Then I break it up into two binomials. Okay. And then I read it backwards. What multiplies to get 8 but adds to get 6 would be 4 times 2. Now since B is... I'm sorry, I skipped a step. Since C is positive, that means they're both going to be the same. And since B is negative, they're both going to be negative. And it doesn't matter where I put 4 and 2 because they're both the same sign.